legal. I cannot just go through and say, oh, I'm going to square each piece. It doesn't work like that. You have to keep your equation balanced. So what you're doing is squaring each side of the equal sign. Now, if I just tried to square right here, what are you going to have to do with those square roots? FOIL. All right, this problem's going to be a little bit ugly no matter what because we have multiple square roots. But it's usually easier to get rid of one at a time rather than trying to FOIL with these because we're going to end up with a really nasty square root when we FOIL. So what I'm going to do first is isolate one of these. So we're going to get rid of one at a time. So isolate it, we want one of them by itself. The easiest option is probably just to add the second square root over. So I isolate one. Now, the opposite of a square root is to square. So I am going to add a square onto each side of this equation. On the left, this is all one term. So what happens if you have a square root and a square? They cancel and we just get 2x plus 3. But on the right, what does it mean to square that? We have two of these. We have to FOIL because it's two terms. So first, 2 times 2 is 4. Plus 2 times the square root of x plus 2 is just 2 square root of x plus 2. Inside, square root of x times plus 2 times 2 is 2 radical x plus 2. Last, when I take the square root of x plus 2 times the square root of x plus 2, x plus 2. Okay, so our little problem has gotten a lot longer. Have I lost anybody? What do you think we need to do now? Yeah. We're going to combine like terms and isolate our radicals again. So 2x plus 3 equals, I'm just going to add like things together. So when I add my radicals, you add the coefficient, so that's 4 times the square root of x plus 2. We have a plus x, and 4 plus 2 would give me a 6. Okay. So if I'm isolating my square root, we have to subtract over the x and the 6. So we get x minus 3. Okay. My radical isn't totally isolated. It does have a coefficient, but it's a single term over there. So you have two choices. You can go ahead and square as it is. Since it's just one term, we won't have to FOIL. If you don't like the 4 there, you can divide by it, but it will give us some fractions to deal with. So do you want to keep it where it is for now? So because we had 2 radicals, we are going to end up squaring a second time. On the left, this was 2 terms, so x minus 3 squared means we have 2 of them. We have to FOIL. So we get x squared minus 3x, and minus 3x is minus 6x. Negative 3 times negative 3 is positive 9. Okay, over here, you're squaring, so you can square each part or think this just means you're taking it times itself. When you do that, 4 times 4 becomes the square root of x plus 2 times the square root of x plus 2. Alright. So a lot of work so far, but it's looking way better. We no longer have any radicals. Plus 32. It's a quadratic, so we need to set it equal to 0. So if I subtract over my 16x, 22x, subtract my 32, does that factor? 23, +1. Set those equal to 0, and we get 23 and -1. Okay, am I done? We have to check it. Also, this reminds me, one of my graphing calculators has walked out of here, so please check your stuff and see if you possibly left with it and get it back to me. So we need to check it. We are plugging these back into the original. So if you put in a 23, so that's the square root of 49 minus the square root of 25. So 7 minus 5 is 2, so that one works. My other answer was -1, so if I put in -1, get the square root of 1 minus the square root of 1, and 1 minus 1 is 0, so that one does not work. So my only answer is 23. That's my solution. Does everyone understand how to check these? That was a lot. Let's try another one like that. Any questions on this one before I move on? Where do we begin? Isolate one. So I'm probably just going to add over the second one. So that's 2 plus the square root of x minus 1. Next step, square. We're squaring each side of the equal sign. So on the left, a square root and a square just cancel one another. On the right, we have to realize that square means I have this whole thing a second time, so we have to FOIL. So we get 4 plus 2 radical x minus 1 plus 2 radical x minus 1 plus the square root of x minus 1 times the square root of x minus 1. Combine my terms. So if I add my radicals together, that's 4 square root of x minus 1 and a plus x, positive 4 and negative 1, make it positive 3. Now what? Isolate that radical. So I'm going to subtract over my x and my 3. Now what? We have to square each side. On the left, there's 2 terms. We have to FOIL, so we get 4x squared minus 4x and minus 4x is minus 8x. Negative 2 times negative 2 is positive 4. On the right, what do we get? 4 squared is 16. For the square root, the square drops that, so we have 16 times x minus 1. And you have to distribute that 16. quadratics, we always set equal to 0. Squared minus 24x plus 20. Now what? Okay. Don't forget your GCF. If you try to slip and slide without taking that out, you won't get the right answer. So we need two numbers that multiply to positive 5 and add to negative 6. Okay, now we set them equal to 0. Does 4 ever equal 0? No, so that won't give me any solutions. X minus 1, what makes that 0? Positive 1. And x minus 5? Positive 5. And then, final step is check it. Okay, we have to plug both 1 and 5 back into the original. So if I put in a 1, I get the square root of 4 minus the square root of 0. So 2 minus 0 is 2. That works. If I put in 5, the square root of 16 minus the square root of 4. So 4 minus 2 is 2, and that one also works. So this time they both checked. We have 2 answers. All right. Longer problems, a lot of steps there. Do you have any questions? Do we need more like that? We will probably do some more tomorrow, but today I'll move on to the final time. Tomorrow we're going to take a day and kind of review all the stuff in this section. So I'm moving on for the moment, but not forever. The last type of problem I want to look at today is something that's called a quadratic type. That means it's kind of like a quadratic, but it's not perfect. Okay, we know a quadratic is ax squared plus bx plus c equals 0. This, it's something square, but it may not be just a perfect x. It might be like x minus 5 squared, and 2 times x minus 5 minus 1. Okay, this is not what we would think of when I say quadratic, but you'll notice I have this to the second, that to the first, and a constant. So it's kind of like a quadratic. Or if I said x to the 6th plus 3x to the 4th, or to the 3rd. Minus 4 equals 0. Okay, this is not a true quadratic because it's not an x squared. But you have x to the 6th. What's half of x to the 6th? X to the 3rd. And then I have a constant. So it's kind of like a quadratic. And so we can use some of our factoring strategies to solve these kinds of problems, even if it's not a perfect quadratic. So we'll look at a few variations of this. There's not only one way of solving these, so we'll talk about different options, what you guys like, what you want to do. I don't care how you solve it, as long as you can. Okay. So let's say I ask for this. Alright. There's probably 3 different options for how we could solve this problem. Do you have any ideas? Yes. Option option 1 is a little more work to begin with, but it turns it into a problem you're used to doing. So option 1 is multiply this all out. Can we do that? Yeah, absolutely. So if we did that, x plus 2 squared means you have 2 of them. So if you FOIL, you get x squared plus 2x plus 2x is plus 4x plus 4. Okay, distribute our 11, so 11x plus 22 minus 12 equals 0. Combine like terms, 4x and 11x would be 15x. Positive 4, positive 22, and negative 12. Okay, how does that factor? Alright, set them equal to 0 and we get negative 14 and negative 1. Alright, and then you could certainly check it, but we didn't add squares in this problem, so our answer should work unless we just made a calculation error along the way. So, option 1 was just multiply it out. Not too hard, you guys are pretty good at distributing and adding like terms. So we could pretty easily turn this into a problem like we're used to doing. Alright, let's look at a similar one and talk about if there was another option. And then you guys can tell me what you like. If you are following along in your book is going to tell you to do a substitution on this. Did you guys ever factor a substitution last year? Does that sound familiar at all? Maybe? Let's see. So you notice we have an s plus 1 squared. We have that s plus 1 just to the first, and we have a constant. So it starts out with making this problem easier to look at. So we usually just pick u or whatever letter you like. And I'm going to use that to replace this s plus 1. That thing in my parentheses. Okay, if I do that, we have 2. Instead of s plus 1, what am I going to write? U squared. Minus 5 times s plus 1, which is u. Okay, I haven't really changed my problem, but I made it easier to look at because now it looks more like a traditional quadratic. So how would you solve this? Okay, you would bring over the 3 and slip inside. So u squared minus 5u minus 6, that would factor into minus 6 and u plus 1, and then what do we have to do? U minus 3 to u plus 1 equals 0. Alright, now what would we do? You set them equal to, you can either go ahead and replace this now, or you could just solve for u first. Either one will be fine. If we just solve, we get u to equal 3 and negative 1/2. But I'm not finished because my problem didn't start with u. What did my problem have to begin with? Okay, so I'm going to come back and now undo my substitution. I'm going to change that u to an s plus 1. So if I subtract my 1, s is positive 2, negative 3/2. Now, if I had to guess, I'm going to assume that probably everybody in here prefers the first way, where you just multiply it out. And that is 100% okay with me. There are some scenarios where we have to have substitution. This is not one of them. Okay, substitution works, but it's not the only way to do these problems. So I know substitution is usually not a favorite method. That's why I will try to show it several times throughout the semester, places where we could use it, so that when we get to the point where we have to, we've seen it. But if you don't like this method, you can certainly multiply it out. Okay. Any questions for me? Final example of the day. Is this a true quadratic? It's not perfect like x squared and x, but isn't it set up like one? So if we were going to solve this, we just wanted to factor x to the 4th. If you split that in half, what do you get? And you know it's working if this is the same as that middle term. Okay, now what multiplies to 40 and adds to negative 13? Okay, if you set those equal to 0, we get x squared equals 8. What would you do? And when you add a square root, you need? So we get a plus and minus. How would you break down 8? Over here, x squared minus 5 equals 0, so x squared is equal to 5. Square root plus and minus, can we break down the square root of 5? No. So we get 4 solutions here. Positive 2 radical 2, negative 2 radical 2, positive radical 5, and negative radical 5. All right. That is where I'm stopping today. So I want to give you guys some time to work. All the book problems are due tomorrow, and then tomorrow we're just practicing all these different types of equations again. So nothing new tomorrow, just a practice day. So you can put this with last night's homework if you have space. Remember, my EOO means every other odd. If you don't like, you can write them all out if you don't want to do EOO. So that'd be 69, 73, 77,